Your toolbox should contain the following items. In the top compartment, you will find a short Ethernet jumper cable, 2 long screwdrivers, a Phillips, and a slotted head, as well as 2 short screwdrivers, also a slotted head and a Phillips. In the main compartment, on the tool tray, you will find a wire cutting and stripping tool, a large Phillips screwdriver, and then a small Phillips screwdriver. Underneath the tool tray, you will find a red plastic cup for collecting your cuttings that you can then throw into the trash, a short Ethernet cable, a long Ethernet cable, and then a black extension cord. Your toolbox should not contain any other items. All of our equipment will be mounted to a wooden board with a handle on it. This is so that when you set up a project, it can be stored in the closet without having to tear everything apart. In the upper left-hand corner, you will find an emergency stop or e-stop button. This is where the power comes into your board. To turn on the power, rotate the button clockwise. To shut off the power, simply press in the button. Do not rotate the button counterclockwise. In the center of the panel is a white metal back plane. This is usually mounted inside of a metal cabinet, but electricians normally wire up the back plane outside of the cabinet and then put it into the cabinet after they have wired everything. This metal piece is called a DIN rail. This is a German acronym spelled DIN that stands for a German Standards Organization. All of the components that we will be using in this class snap to the DIN rail. Most items simply snap onto the DIN rail. Place the top onto the rail and snap the bottom into place. To remove, place a screwdriver into the slot on the bottom and pry it up. Here you can see how the screwdriver fits into the slot. This is called a terminal block. It connects a wire from one side to the other side using a small metal jumper in the middle. Only place wires into the terminal block with ferrules that have the dimples facing out. When placing terminal blocks onto the DIN rail, always be sure that the fins are facing to the right. This item is called a divider. You will notice that it has some raised features on the left, but not on the right. Always place these features to the left into the slots on the terminal blocks adjacent to it. Then slide the terminal blocks on the right against it. Items on the DIN rail can slide back and forth. In order to hold items in place, we use what's called an end stop. Once again, we want the fins to face to the right. The end stop has a different clipping method. Instead of clipping the top on first, you place it directly on the DIN rail and use a screwdriver to tighten it down. In the upper left-hand corner is where power comes into the board. On the left, we have a green and yellow earth ground terminal block that is connected to the DIN rail and is also grounded to the backplane. Then the line comes into 2 black terminal blocks and the neutral comes into 2 white terminal blocks. All of these blocks need to be separated by dividers. Then we will have a black and white pair of terminal blocks. Adjacent terminal blocks should be connected with orange jumpers that go into the holes in the center of the blocks. This is what one of the jumpers looks like. To connect it, simply insert it into the holes in the center of the terminal block. If you need jumpers of different lengths, they come on a long strip that can be cut to length using your wire cutters. On the top rail is where you will begin to place your control equipment. On the left, you usually have a power supply. This converts the 120 volts AC that comes in from the wall into 24 volts DC that's distributed to the other components. The next module is a communications module that's connected using an Ethernet cable to the PLC and also over to the screen with a longer cable. All of the modules have covers on the top and bottom that cover the terminal blocks. Some are purely decorative though. Each of these flaps can be removed simply by pulling out on both sides. Each of these items on the DIN rail can be removed with a screwdriver by placing it into the clip on the bottom and pulling up on the bottom of the unit. To replace a unit, be sure the clips on the top and the bottom are both snapped back into place. Then place the top of the unit on the DIN rail and push down firmly with both hands until the unit snaps into place. When placing wires into the PLC, be sure to use ferrules with the dimpled side facing outward. Use only the small screwdriver with the PLC. Place the wire into the terminal block and tighten the screw down onto the ferrule. One of the nice features of the Siemens PLCs is that the entire terminal block on the top and bottom can be removed with a screwdriver simply by prying it up. The terminal strip can simply be snapped back into place. 120 volt AC power comes into the upper left-hand side of the power supply, and then 24 volt DC power comes out of the upper right-hand side. One of the unique features of the Siemens PLC is the labeling of these terminals. On the front center of each PLC, you will find a small cover that you will need to pry off with a screwdriver at the top until it pops off. Then you will place an analog output module into this spot by simply snapping it into place. Terminal strip covers can then be snapped back into place. This item is called a signal conditioner, and you will be placing it on the bottom rail. It has clips on the back just like the PLCs. To put it into place, you will place the top on the DIN rail and snap it into place. To remove it, you can pry on either the top or the bottom. These are special terminal blocks that fit together with pins on the side of one, fitting into holes on the side of the other. These are designed to be used with special green removable connectors. In this case, we will be placing them onto the DIN rail with the fins facing to the left. It may be easier to place them on individually, and then, after you've clipped them into place, slide them together. Also, on the bottom rung, you will place a socket for what's called an octal relay. This is a kind of socket that was used on old vacuum tubes. This allows you to simply snap the relay into the socket and pull it out of the socket very easily. The socket snaps onto the DIN rail like all the other components and can then be removed with a screwdriver in the tab on the bottom. And finally, you will be placing a 12 volt power supply on the bottom DIN rail. Some of you will be using smaller 12 volt power supplies of different sizes. In this course, we will be using wire color to denote polarity of 24 volt wiring. You might use black to denote negative and white to denote positive DC voltage. In addition, we will use black to denote line and white to denote neutral of 120 volt AC power. Be very careful to note the labeling on the power supply so that you connect the high voltage to the correct terminals. In the United States, wire diameter is denoted using the American Wire Gauge Scale, otherwise known as AWG. On this scale, a smaller number denotes a larger diameter. This is in contrast to what is used in the rest of the world, which is simply a measure of the diameter of the wire in millimeters. In our course, we will mostly be using 18 gauge wire. You will note that this tool states that it should only be used for cutting copper. At the tip of the tool are some plier jaws, and next you will find a little area that can be used for crimping certain types of connectors. And then we have all of these different holes that can be used for stripping wire. In addition, you will find a cutting area down here that can be used for cutting wire only up to 16 gauge. So to cut a wire, you simply pass it through and snip it off. To strip a wire, you place it in the correct slot, perpendicular, and then pull to get the sheath off of the wire. After you strip the wire, you should twist the ends of the wire together, holding the wire in your left hand and twisting with your right hand in a clockwise motion. In order to keep the strands of wire together, we will be using a ferrule that will be crimped onto the end of the wire. To do this, we will slip it over the end of the wire, and then we will use one of two crimping tools. And in this case, with the red handle tool, you'll want to use the very end crimping area. You will place the ferrule in the tool and crimp the tool all the way down until it's tight. And now you'll notice that we have three little dimples here on the ferrule, and the end should be in a trapezoidal shape. With the blue crimp tool, you should use the second slot, and then you can trim off any excess copper sticking out beyond the end of the ferrule.